So today we'll see LinkedHashSet. One more class which is supporting collections. Okay, so we'll be seeing this class today. If you see the hierarchy, okay, LinkedHashSet is a subclass. You can see it is extending. Okay, straight arrow mark indicates extends, but it is implementing what? Set. Okay, and again set is extending what? Collection. So if you see now, LinkedHashSet is extending HashSet and implementing set and collection. So this is the hierarchy now. So now, what is the behavior of LinkedHashSet? How does it behave? Okay, so it has the same functionality of HashSet, nothing difference, no difference only. What is that? Maximum means all things are same. Now thing is, see, HashSet does not allow what? Duplicates. HashSet does not allow duplicates. Same. It does not allow null values. Which one? Sorry, HashSet does not allow duplicates but allows null values and dissimilar data. Same with HashSet also. It does not allow duplicates but allows null values and dissimilar data. But only difference which comes out is, okay, HashSet does not store the elements in the same order as inserted. Yes, but LinkedHashSet stores the elements in the same order as inserted. So in what order you insert, it will store it in the same order. Understood? So in HashSet what happens? It will be storing in random order. It is the order is not guaranteed. You might insert in some order, but it will be storing in some order. But in LinkedHashSet, it will be storing in the same order as inserted. That is all about LinkedHashSet. Yeah. So what are the things you have to study now? So to prove that, I have to give some example now. What example? LinkedHashSet does not allow duplicates. So we have to cover these points now. Does not allow duplicates. It allows nulls and dissimilar data. Understood? And it will store the values in the same order as inserted. If I cover this much, done. So we'll see some examples straight away. So I'm going with the 8th project today. 8th LinkedHashSet examples. The first program is the same one, only the data structure changes. Which one? Create a new LinkedHashSet. Initial size would be what? 0. Is empty is true. Elements would be nothing. See, I'm adding the elements in this order. Yes. Plus I'm adding what? Null value. Fine. So in what order are you inserting? Same order it will store now. So we'll see that. So size will be whatever we'll see, and is empty will be what now? False. So then again I can check contains. Okay, so here also in LinkedHashSet, search is very fast. Okay, so get the point. LinkedHashSet means what? It uses hashing technique only. So we'll come to that point. I'll explain about the data structure later to you, but here search is very fast. I'm just talking about how it executes. Then I'll talk about the data structure. What data structure it uses internally, you'll be seeing that later. Done? So then remove. Then clear. These are the same methods what we are seeing now. Let's see this now. You can run the program and check. Yes, initial size is 0. Before adding the values, is empty is true. Okay, there are no elements. Then we added 7 elements. See, this is the order what I inserted. Yes or no? See the order what I inserted. C, A, E, B, D, F. Then what? Null. Can you see the order here? It is inserting in the same order. So it is storing in the same order. It is storing the same order in which you are inserting. Okay. Then is value is present true, value R is present false. Okay, I'll delete. Now after deletion it is 6. Then you can see the contents. I can call the clear. After clearing, how many elements are there? 0. And there are no elements in the set now. Same. Understood? So ditto to ditto. About what? HashSet. Only thing is, it will store it in the same order as you are inserting. See, I try to add a duplicate. It will not insert. This is duplicate now. A is already here now. So I'm trying to add a duplicate. How many A's are there now? Only one, which clearly shows that it doesn't allow duplicates. Fine. This is a simple program now. The next program, we'll see all the things. See, it can, the same concept now. It can add what? Dissimilar and null values, but it cannot add duplicates. Same. See here. Here I'm only one thing what I'm showing is I'm adding a dissimilar data, nothing else. Understood? See, you can add dissimilar, yes or no? Along with strings, what I am adding? Integer. And I can add null value. Yes, I am adding null. But here, I cannot add duplicate. Yes, try to add D. D is already there now. It will not? Hello, it will skip. And it is storing the same order as your inserting. That's it. Understood? Now coming to the one more example, third example. I am showing you how to add primitives here. When you are adding primitives, all collection classes can store only object. Remember that. So you have to convert them into objects and store. Means I will use wrapper classes. I will do boxing and then I will store. So then this is the one. And in the same program what we are seeing? Iteration. Okay, how to visit the elements. So I am using what to visit the elements? Iterator. I cannot use what? List, iterator and enumeration. I cannot use these two. So if you want to visit the elements in a LinkedHashSet, I can use only iterator, nothing else. So I can see this output. One is direct output, SOP set, 2 string output. The other one is using a iterator. Done? Okay. So that's all you have to understand about LinkedHashSet. But if you want to know a little bit more about what data structure it is using internally, that I'll tell you, no problem. But from the top view, you have to understand only this much about LinkedHashSet. As a developer, you should understand only this much. So let us see which data structure it uses. Clear? Can you guess which data structure it uses? It uses a combination of HashSet plus linked list. It is using the LinkedHashSet is having a combined implementation of HashSet plus linked list. Combined implementation. Okay. So let's see how the elements are stored now. So it stores some values like this: C, A, E, B, D, F. Okay. So I told you it is having a combined implementation of what? It means it will be storing the values. When it is having a combined implementation of that, means it stores which data structure it uses now. It uses 2 data structures to store now. One is hash table and the other one is linked list. So this uses 2 data structures now. Which one? LinkedHashSet uses 2 data structures, not one. Okay. It is using hash table plus linked list. Supposingly I say now, see this. I'll say LinkedHashSet set is equal to new LinkedHashSet. Write it fully. Okay. So now I'll say set dot add. See the elements I'm adding. Set dot add of what? C, A, E, B, D, F. I am adding all these elements now. Means they are all strings. So now how it should be stored is it will be using 2 data structures. Which one? One is hash table plus other one is linked list. So first thing, let us see now. When you create an object of LinkedHashSet, in fact, you will have one hash table created with 16 buckets or 16 slots. Same behavior. 16 buckets or 16 slots. So this here you will have the hash code and here you will have the value. Like this you will have how many? 16. That is the default. See what you learned in HashSet? Same here. It has 16 buckets totally. Okay, these buckets are sometimes called as what? Slots. That's the terminology they use here. Okay. So like this, many slots will be there or buckets will be there. So when I'm adding now, what it does is internally C, I'm saying. So the C value, hash code will be calculated now. Okay, and by default string is implementing what? It's overriding. Okay, string is overriding what? Hash code method. So it will get the hash code value. And see, yesterday means or in the last class I was showing you, I was putting the values one after the other. It's not like that. The hash code decides in which bucket it will store. It can put it into any of the 16 bucket. They have their own algorithms. Okay, so assuming that out of the 16 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, okay, 16. In the 16 slots or buckets, what you got? If the hash code of C is something like 59859, something like this, okay, so what it will do, it decides to put that element in some slot. Which slot? 1, 2, 3, 4, 5, 6 slot. They have their own algorithms. This is the hash code and that is the value. Next, A will be stored. A can be stored where? Depending on the hash code. It can be stored here. 5 or something like 4, 8, 2, 5, 9, something like this, and A can be stored here. Okay, in another slot. So it is the hash code which decides in which slot or bucket the element will be stored. Understood? So then again I'll add something F. So supposing it is 6, 5, 2, 8, 9, 5. F will be stored here. Like this it goes on storing. So that is why the elements in hash set are always stored in random order. You can't predict the order. Okay, because it will be stored based on the hash code. Okay, then CA, what I added? E, no? Okay, I assume that this is the third element. E. Then B I will add. B will be added here now. 7, 5, 2, 8. B. Then D. Five, 6, 5, 9, 8. So D will be added here. Last element is what? F. So 9, 8, 5, 2, 1. So like this. All the elements will be stored. So when you print SOP set, supposing list of linked hash set. If I had used hash set, this is how it would have been stored. And when you print, it will print it in the random order. That's how the hash set works. Understood now? Yes. A linked hash set is one step extra. That's it. If I just use linked hash set, what it will do now? First element what I added? C. Fine. It will add in this bucket. Correct. It will calculate the hash code and all that. It will add it. Next, which element I am adding? A. So it will link with help of what? Double linked list. Pre-next. All that will come. It will link. Then I am adding what? E. So where is E? Okay. Again it will link. Double linked list. So it goes on linking. Then what I am adding? B. Now E will be linked with what? B. You know pre-next no? So like that it will link. That's it. Then B will be linked with what? D. Okay. So like this it goes on linking. Now D will be linked with what? F. That's all. So that is why you get the elements in the same order as inserted, nothing else. It's a combined implementation of hash table plus linked list. Understand now? So that's how it works. So now why do you use linked hash set? You might be getting the answer now. When you want fast search rates plus you want the elements in the same order as inserted and you don't want duplicates. So in that cases what you will do? You will go for linked hash set. That's it. So it is a very complicated data structure. Yes or no? To implement for us it is very difficult. So what does Java say? Don't bother. We already have got it for you. Just use it. It's there in the library. Instead of you writing it, just create an object of the class called as linked hash set. It will support you. That's it they are telling. Clear now? Okay. So it is having a combined implementation of hash table data structure plus linked list data structure. Understood? These are rough diagrams I am giving you. Just get the concept. You should only worry what now? It will not allow duplicates. That's all you have to worry. It will not allow duplicates. Okay. It will allow dissimilar data. It will allow null values, and it will store the elements in the same order as inserted. That is all. As a developer you have to worry. This is just to give you a concrete picture so that you don't forget. Okay. That throughout your lifetime that this is how it works. One pictorial idea I am giving you. Understood? Yes, are you getting this idea now? How these values are stored? C, A, E, B, D, whatever is stored now. This is how it will be stored in linked hash set. Okay. So that is why when you run the program now, what happens? It will be storing it in the same order as inserting. But in hash set, it was not linked. It was giving you in a random order. Getting it now? Fine. Yeah. Now coming to the document, we'll see. We'll first see the Java doc, linked hash set. Almost all you know everything now. Just I have to highlight the constructors and finish it off. How many constructors are there? Should I clear now all this? Clear now? Yeah. So we work with this constructor, yes? So see, here constructs a new empty linked asset with a default initial capacity of 16 elements and load factor of how much? 0.75. Means what does that mean? So totally you'll have 16 elements here. Understood? Or okay, I'll write here 16 elements. Totally you'll be having 16 elements. As soon as you can see this now 0.75. Can you see? Somewhere, okay. The load factor is how much? 0.75. Okay, so just see that. So what happens as soon as 12 elements are filled now? As soon as what happens? 12 means 75% of is filled. Okay, as soon as this much is filled, 12 elements are filled, what happens? Means 75% of is filled. Again, just drawing it in dotted line, okay, space for 16 more elements will be allocated. Actually they say books tell what? Elements, 16 more elements, space for 16 more elements, but it is actually 16 buckets or slots which it will be allocating. 16 more elements will be allocated, means 16 slots or buckets will be allocated. So this is the dotted line, again it grows. Again 75% of that fills, again it grows. Means it will be maintaining the buckets. So that any element is added, it can calculate the hash code and store it into that bucket. That's it. Bucket or slot, nothing else. Are you clear with this? Yes. Now coming to the next constructor. Which constructor? This you know. Which one? You can pass any collection. If you want, you can pass any collection into this. Array list I can pass it into what? Linked hash set. List set also I can pass all that. Fine. Now coming to this constructor. Int initial capacity. If I pass the element like 8, what happens? First 8 slots will be allocated. Okay. And as soon as 75% default load factor will be what? It will be using the same load factor, 0.75 only. So as soon as 6 elements are filled, again 8 more will be allocated. Understanding now? So if you use this constructor, first how many slots will be there? 8 elements. Memory for 8 elements will be allocated. As soon as 6 are filled, means 75%. Default is filling, load factor is what? 0.75. As soon as it is filled, again how many elements? 8. 8 more elements or buckets. Okay, 75%. Now the last one you have got one more constructor, which one? Initial capacity, load factor. So here you can decide load factor also you can decide, capacity also you can decide. Like instead of like this, say I want initial capacity to be 20, load factor to be what? 0.5. Means as soon as elements are filled, again it will increase by 20. Like that. So you decide. So these are the 3 constructors, what 4 constructors what I got. 1, 2, 3, 4. Same as what? Hash set. Nothing different. Same as hash set. What we discussed in the last class. Yeah? So that's about the constructor. Are you clear with all this now? Okay. You got this constructor now? Capacity and load factor, fine. Okay, so that's all about the LinkedHashSet. I will see some documents about LinkedHashSet. Project is a bit slow, 1 second. So now we'll see the notes for LinkedHashSet. So LinkedHashSet is a topic what we are discussing. So LinkedHashSet as a combined implementation of what? Hash table and linked list. The LinkedHashSet stores elements in hash table and links them with double linked list. Values are stored in the same order as inserted and are unsorted. That is very important. Different types of objects are allowed. Different type of objects. Null value is allowed. Duplicates are not allowed. And LinkedHashSet can use only iterator but not enumeration and list iterator. Fine. Next question now. When do you use a LinkedHashSet? You use this class when you want fast searches plus what? When you want the elements to be added in the, accessed. When you want the elements to be accessed in the same order as inserted. When do you use LinkedHashSet? Only this much. Now differences and similarity. Yeah, now see the difference and similarity. HashSet stores elements in what? Hash table. LinkedHashSet stores elements in a hash table and links them with double linked list. Elements are unordered and undefined or undefined, but their elements are stored in the same order as inserted. Now that was the difference. Similarity, both are not synchronized, both do not allow duplicate values, both allow different type of objects. Null values are allowed, both provide very fast search rate. Okay, both are eligible for cloning and serialization. Both can use only iterator but not list iterator and enumeration. That's all. Now finally, we'll put the nail into the coffin. Explain the different scenarios you will use the different collection classes. There's one small table I got for you which will completely give you a clear idea about which data structure to be used when, or which collection class to be used when. I'm talking about the main classes, we are not talking about legacy here, vector, stack and all that. See this array list, linked list, tree set, hash set, LinkedHashSet are what? Collection classes. How does it store the elements? Like this, it allows duplicates, nulls and dissimilar data. It stores values in the same order as inserted, and it is very good in what? Iteration. Means you can access the elements fast when you iterate. And what data structure it is implementing? Array data structure. Next, linked list. It allows duplicates, null and dissimilar data. Same. But extra thing is what? It stores values in the same order as inserted. Tree set. Okay, sorry. It should be used when too many insertions and deletions are performed. Okay, which data structure it is implementing or encapsulating? Linked list. Tree set. It allows only similar type of data. Then it doesn't allow duplicates, null and dissimilar data. And also it stores the values in sorted order. And should be used when sorting is required. Which data structure? Tree data structure. Hash set. It allows dissimilar and null values, doesn't allow duplicates. It stores values in random order. Search rate is very fast. Performance wise if you see, search rate is very fast. And it is implementing hash table. Same LinkedHashSet, it allows just now what you saw. Okay, it allows dissimilar and null values. It doesn't allow duplicates. It stores values in the same order as inserted. Search rate is fast and can access elements in the same order as inserted. So it's a combination of hash table and linked list. That's it. Means it is implementing two data structures. Simple as that. Clear? So see, the data structure is so complicated, but Java has made working with data structures in such a simple way because of its library. Okay. And finally, to conclude LinkedHashSet, remember if you want to add user defined data in LinkedHashSet, what is the rule? You should override hash code plus equals method. Otherwise you know the problems. Okay, while inserting, duplicates will be added. If you don't override hash code and equals, duplicates will be added. For user defined type, I'm telling, which one employee and all that, you have to override. Understood? So if you are inserting, you should override equals and hash code. If you don't override, you know the problems. Duplicates will be added, and while searching, you can't find your object. So those two problems you know. Clear? Why LinkedHashSet has to override, means why you have to override the elements, why should you override the hash code and equals method when you are storing in the elements in LinkedHashSet? Because this is using hashing technique. Because it is using hashing technique. So the name itself is very clear. Okay, which classes use hashing technique now? Which collection class uses hashing technique? They'll have the name as hash. Okay, hash set, LinkedHashSet, more will come. Hash table, hash map. So all that, what you have to understand is they use hashing technique. So whenever you are adding elements into those collection classes, remember that you have to override hash code and equals method. That's it. Yeah. So this is the final summary of till now what you have studied. Yeah, fine then. So in the interview you should be able to tell now which data structure to use when. Okay, so these are all extensively used, but maximum used are array list and hash set only. Maximum. Fine then. Yes, coming to summarize. Okay, see here. You have got list interface. Yes or no? How many classes are implementing list? Stack, vector, then array list, then linked list. So there are 4 classes which are implementing list. Then you got something called as set. Which are they? Hash set and tree set. Then you got one more called as sorted set. Here you got only hash set and linked hash set. Linked hash set. Here you got tree set. Okay. So say any class which is implementing list will allow what? Duplicates. That's what you have to understand now. These two will not allow, means any class which implements set will not allow duplicates. Here will not allow duplicates plus what? Plus sorted. Here it is unsorted plus unsorted here. Here means that's the difference between set and sorted set. Yeah? So fine. And again if you notice, collection is the super interface for list set and sorted set. So now clearly understand, data structure is a very complicated subject. Okay, because data structure involves, so many data structures have been evolved over the years. Okay, and to support those complicated data structures, Java says you don't go on writing in preparing the data engine. We had discussed this in the first session of when we started collections. Okay, whenever you want to use any data structure, you don't sit and design your data engine. Okay, just you use it. We already given you the implementation. That's what they say. And that too, how beautifully they are given is, okay, if you want to work with any structure, you have a standard way of working with it. That's what is called as a collections framework. Understood? See this now. How support you get now? See, if you want, I can say a list is equal to, I can use, to work with the data structures, I can use dynamic polymorphism. Yes? See the benefit in Java. Now, already implementation has been done. That facility is there for you. You just have to use it. On top of that, they are giving you the support of what? Dynamic polymorphism. List is equal to array list. Array list. And you can fill all your values. List dot add and you can fill all the values. Yes or no? Fine. Tomorrow you don't like array list, I'll change it to what? Linked list. See? This is dynamic polymorphism. This is how you use the dynamic polymorphism. It's always advisable to create, to use collection classes in this way only. Okay, so this is decoupling. Okay, so whenever you want, you can change your data structure only. Yes or no? Can you change data structures in other languages like this? Very difficult. Okay, implementation you have to do, then you have to change. So many things will change. But here, because of the standard, see, add is a common method where now in both the interfaces. You can use it. Nothing will change now. Add, contains, these are all common methods. Now let it be linked list or array list. Why should I bother? Only the data structure is changing. So I got a uniform approach of working with any data structure here. That is the benefit you get in Java. Okay, in other languages you have to study, implement, use. Changing in the project means ruled out. Actually it will be a nightmare, but in Java it's so flexible. Understood? So always you go with this approach only rather than writing what? Array list, list is equal to new array list. Don't do that. Okay, so always it's better a practice to use superclass variable to subclass object. That is nothing but dynamic polymorphism, because you can change your implementations later. Understood? Okay. Then same way here also, set is equal to new hash set, or you can change it to what? Tree set or LinkedHashSet, anything. So that is the better way now to work. Understood? This is again dynamic polymorphism. You have got one more approach. If you want, you can do this very high level also. Collection C is equal to new what? Which data structure you want to tell? Collection is a super interface now. Tell now. That is still high level. Understood? Which data structure you want to tell? Finished. So easy it is. So that is the beauty of Java. Even though data structure is so complicated, it has brought it down to earth to work for the developers. Understood? So one support it give with the help of dynamic polymorphism. Clear? Collection C is equal to new what I'll say? Linked list. Fine. Or I can also say array list, or also I can say stack. But this much of dynamic binding will not do. Generally we'll be doing like this only. Why we do like this means list is equal to new array list means now people will understand, okay, here duplicates are expected. Set is equal to new hash set means they'll understand here duplicates are not allowed. They'll get the idea. But here collection C is equal to new linked list, if you say, when I look at C now I'll never understand whether duplicates are there or not there. So it becomes very confusing to work. So better you follow this approach, which is list is equal to new array list. See, think from practical point of view. You know dynamic binding will happen. Doesn't mean that you'll bind it in this way. So you should know the accurate way of binding it. Clear this? Fine. Then next, one more thing. See here. I got some values in array list. Array list, list. See the flexibility in Java. Array list is equal to new array list. I've added the elements. List dot add something like C, list dot add A, list dot add E, list dot add B. Now I want to, supposingly there is one duplicate, list dot add something like A. I want to remove the duplicate. Some scenarios will come, or some whatever scenario. Now all I want to do is, okay, right now I am using which data structure here? Array structure. Now I want to transfer all the elements from array structure to tree structure. Fine, fraction of second you can do. What will you do? Tree set, TS is equal to new tree set of list. Finished. See, from one structure you are putting it into another structure. What flexibility you got here in Java? You can change your implementations, or if you want you can transfer elements from one data structure to another data structure. What brilliant it is. So that is the support what Java gives you for working with all the complicated data structures. Done? Yes. So just I summarized till now what you covered. Shall I clear all this now? Yes. So now let us see one more thing now. Okay. See here, to prepare the library, Java used which data types? They are using class, interface, subclasses. So get the idea now. When to use class, when to use subclass, when to use abstract class, when to use interface. You should get the idea now. So classes are used. Now let us revise what we studied the data types. Okay. So classes are used when you want to do what? Concrete implementations. Subclasses are used when you want to change the implementations. Okay, and abstract classes are used when you want to do partial implementations, and interfaces are used when you do not want to do any implementations. Yes, and you can see a beautiful usage of interfaces. Collection, list, set and all that, they are not doing any implementations, but instead they are making subclasses do the implementations. So what is the benefit of interface now? Yes, we can set standards. You can revise the topics now. You can set standards, okay, and you are decoupling declaration and implementation. You are not implementing in the class, okay. Declaration will be done in the interface. Implementation is done where? In the classes implementing it. What is the benefit of it? Dynamic polymorphism. Understood? So you can change your implementations in a better way. So means yeah, that is one thing. Then other things about interfaces help you to set standards. They always tell you what to do but not how to do. Yes or no? Some more point we have discussed. So I'll tell list.add. So it will add the element. Okay, I'll say set.add. It is adding the element. But remember, behind the scene there is some other data structure. Look at the way they are changing the logic. In this class they are having a different logic. In that class they are having a different logic. But it will do only add. Add means it will only add. It will not do anything else. So interfaces state always what they do, but not how it is done. The implementation will change because it will depend on data structure. Understood? So this is how we use data types for programming. Java's data types are very rich and powerful, and also they are platform independent. Understood? So now we have seen the best implementation of OOPS. What is OOPS now? What is OOPS, sir? Encapsulation. Yes, sir? Inheritance, polymorphism, abstraction. So if you want to implement this 4, you can choose any of the data type. If you want to implement this 4, Java is giving you very powerful support for implementing OOPS. Understood? It's giving you very powerful support. What support it gives you? 4 data types. Unlike other languages like C++, which gives you 3 data types, Java is giving you one more powerful data type called as interface, which is not there in that C++ language, and you know the benefit of an interface now. So it is through years of experience they invented that particular data type. Understood? So initially it was introduced to support multiple inheritance, but later on it is being used for so many other purposes also. Okay, there are many advantages of interface. Just I highlighted how an interface can be used in programming. That's it. Understood? So if you are good with data types, it becomes very easy for you to browse through the library. Okay, which class, when, how they are doing, what they are doing, it will be very easy for you. Okay, so this is how, so to implement OOPS, see, to implement encapsulation, inheritance, polymorphism, abstraction. So what the Java is giving you? 4 data types: class, subclass, abstract class, interface. Now again, how will you decide to choose when to use class for implementing OOPS? When you want to do concrete implementation. When you will decide to use subclass for doing implementing OOPS? Add or modify implementations. Okay, how will you, when you will choose abstract class to do implement OOPS? Partially, same way. When you use interface to implement OOPS? No implementation. And here I got a beautiful example of list, set, interface and all that. Understood? So there also we are implementing OOPS only, but I don't want to do any implementation. Okay, so and see this. A list, again I'll repeat it, list is equal to new array list. Fine, list.add. You're adding an element, fine. List.add E, it's getting added in the array structure. But suddenly if we change it to linked list, fine, it works. Now how it is working, why are you bothered? That is abstraction. Abstraction means you really don't know how it works, but you'll get the output. It's unclear for you. The real meaning of abstraction is unclear. You don't know how it is working, but it will work for you perfectly in the same way what you require. So many things which are ready, you just have to use it. You don't have to reinvent it here. Understood? So for implementing abstraction or for achieving abstraction, which data type did they choose? Interface. Yes or no? So interface provides you very high level of abstraction. Okay, because interface will be there. Now many classes will be implementing it. Which class you want, create the object, start using. And you don't know how it works. Understood? And that is where you get the meaning. It's an interface to that. See, to work with object, what you need? References. Yes or no? Here to work with object, what I am using? An interface. That is the actual meaning of interface. I'll make it still more clearer when I teach you more advanced technologies. Okay, interface means to work with objects, what do you need? Means, see, always to work with complexities, what do you need? Interfaces. You know actual meaning of interface, huh? I'm just trying to explain what is an interface today. Okay. See, always when there is a complexity, okay, you need an interface to work with that complexity. It's a rule. Otherwise, you can't work with the complexity. Like TV is there. Okay, it's having too much of complexity inside it. To work with that complexity, what you have got? Remote, no? So remote is the interface to the TV. Okay, that is one example. More examples I'll give. You know operating system, no? Operating system is very, very complicated. Yes or no? Okay. Now it is installed where? In your hard disk. Now if can you, to work with the operating system, can I work with the operating system directly? No, you can't work. So you need an interface to work with what? That operating system. Now can you guess which is the interface to work with the operating system? Desktop. If I want to work with the operating system, it's a complex thing. So I have to use what? One interface. Remember that. Always complexity is hidden behind. But if you want to work with that complexity, you need an interface. Same thing is happening here. The complexity is what? Linked list, array list. But if you want to work with that complexity, what are you using? List. So they wanted to give a good name to this data type. Understood? They wanted to give a very good name to this data type. That's when they decided to give the name as interface. It's an interface to that object, or it's an interface to that implementation. Understood, no? Because generally people never have understood the real meaning of interface, because it looks quite odd. They are called as class, subclass, abstract class. That looks okay. But why the name interface for this data type? The question comes up. Understood? So it is an interface to some object or complexity. More clearly you'll understand when I talk about, when you see the library more, no? Here hardly you are seeing how many interfaces? 4 or 5. When you start seeing more interfaces, you still start getting more and more clear idea about why an interface is used, what is the advantage of using an interface and all that. Okay, see, this is an interface now. To work with the operating system, I'm using desktop now. I'll click start. So this is how you're working. This is an interface. Without this, can you work with the operating system? Where is the operating system? In hard disk. So to work with any complexity, you need one interface. This is an interface. So to work with linked list, I can use list interface. Or I can work with array list, I can use list interface. That is the idea, a simple introduction. Clear? So almost now we have completed which one? That hierarchy now. Okay, fine. And along with that we saw how we little discussed about OOPs and all the data types and why Java is so powerful in programming now. And at the same time it is what? After giving you such rich libraries, beauty of Java languages, it is platform independent. So what you learn once, it is for lifetime now. Understood? It is for lifetime, and you can run your code in any operating system of the world. That is the beauty of this language. Clear this? I think that would end today's class. That's it.